Hello, we are Group 6. We did a project called the ping-pong database, which is an idea of having the database acting as the game engine. One of the biggest challenges is being able to serve multiple users simultaneously, fast, and yet keeping concurrent. And with the different concurrency methods that are available, it could be an interesting observation performance-wise to see the difference of them, and the effect of having them combined. The main goal of the project is to analyze the efficiency of different concurrent methods during intense operations being done on a database, and also to see if there's a possibility to have a database as a game engine to some extent. Our hypothesis for this project is that the optimistic method will be the fastest, and then the blocking and lastly the restarting method. There will be no visible difference between the methods in the concurrency when playing the game that the player can see, but will affect latency, and that is visible to the player. These are the three main methods that can be implemented as a concurrency control. And in this project, as well as paper, we are looking on the optimistic blocking and blocking restarting method. These are solely implemented in SQL query form. The implementation consists of two parts, the database and the web server to handle requests and hosting the website. We'll begin by taking a look at the database structure. The database consists of three tables, as you can see. They do not have any prime keys, so the values are independent from each other. There's no reference or any of that kind of relations between them. For the game logic, we have defined four functions. Update ball function, check score, manage collision, and check collision. And there's two triggers, a score trigger and a beat collision trigger. The update ball function simply calculates the next position for the ball. Check score will assign points to the player depending on the type of collision. If the ball hits a wall, then it's a point. If it's a paddle, it's none. Manage collision function will try to resolve a collision, and the check collision will return a value that indicates the type of collision. Both triggers will be triggered by an update on the table ball. They will be triggered in alphabetic order, which results that in A score will be the first one to trigger, and it will call check score function. And then we have the B trigger, and as you can see from this sequence diagram, it will call the manage collision, which in turn will call check collision, and from there it will handle if there's any collision. The only thing that is interesting on the website is how the requests are sent. The request is sent as soon as result from the previous call has returned, and is done via Ajax to communicate with the PHP. The PHP then takes the information sent from the player, which is the player's position. PHP then sends the queries to the database and handles the results and send them back as an array to the website. Here we have the queries that is sent to the database. This example is of the blocking method. At the beginning of the transaction, we lock the player table, and then if a new transaction wants to have access to it, it have to wait for its turn. In the restarting method, we put the condition no wait that aborts transaction if the table is occupied. This graph is the average delay when playing a game for some time. These are three separate sessions, which are both of the players had the same methods. With the results, we can see that our hypothesis was correct. Now if you look at this result from where player 1 had a blocking method and player 2 had a restarting method, we can see this still agrees with the previous graph. The restarting method is still the slowest. And here we have a demonstration video that is showing what the game looked like and how it acted. So, because we implemented diff methods as queries, and for example with the starting method, we had to wait and see if the locker sent back an error to PHP. If that was the case, a new session was to be sent. This has an effect on latency. That's one factor why the restarting method is so much higher. So the optimal method for our project is the optimistic method. The result and our hypothesis is agreeing with each other. One of the problems we had trying to use database scheduler because we wanted everything to solely inside the database, but because of the limitation of schedulers not being able to have an interval less than 1 second, we had to resort to using a bash script that had an interval of 10 milliseconds. And a conclusion about making a database act as a game engine is that it's not an optimal way to create a game. So thank you for watching our presentation. Have a good day.